Hello and welcome. In this video, we will take a closer look at the wideband transceivers that are modeled in ADIsimRF. ADIsimRF contains device models for the AD9361 and AD9371 wideband transceivers. These models can simulate noise, third-order intermodulation distortion, and the power levels in the main receive and transmit signal paths of these devices. The current library contains a receive path model for AD9371, along with transmit path models for AD9361 and AD9371. Let's take a look first at the model for the AD9371's receive path. To find this in the pull-down menus, we first switch to receive mode by hitting the TX/RX toggle button. We can find the AD9371 model by clicking on the device pull-down menu and selecting Transceiver RX. And then in the part number pull-down, select AD9371 RX. This model is easy to configure. First, we select the input frequency, and then we select the gain of the input VGA. So we first select a frequency of 900 MHz, and then we will set gain to its max level. We can get a sense for the relationship between the maximum input signal as it relates to gain as follows. We know that the internal ADC of this device has full-scale input voltage of 1 volt peak to peak. If we set the gain to its maximum using the gain pull-down and apply the recommended max input power of -14 dBm, we see in the analysis frame that the peak-to-peak voltage of the ADC is 1 volt. Notice also that the RMS and peak backoff boxes have lit up to warn that we are coming close to full scale. From here we can adjust the ADC drive level by adjusting the gain or the input signal level. One other thing worth noting is that the analysis bandwidth in the input frame should be adjusted to correspond with the baseband bandwidth that you plan to program in the AD9371. This will result in correct SNR calculations. Now let's take a look at the transmit model for AD9371. First, we toggle into TX mode. Because the AD9371 has two ways to adjust output signal level, namely the dBFS level of the DAC and the attenuation of the DSA, the model is spread over two stages. We can load these models from the transceiver TX pull-down and from the DSA pull-down menus. When we set the dBFS level of the DAC to its highest level and set the DSA to minimum, we get the familiar +7 dBm nominal max output power that is specified in the datasheet. From here we can adjust the dBFS level and the attenuation of the DSA to get the desired output power level. Note that when using this model, the input power level in the input frame should always be set to 0 dBms. In the example signal chains folder that ships with the software, there is a complete signal chain that is built around the AD9371. This includes the ADL5335 DGA, which is designed to interface directly with the AD9371's differential outputs. Thank you for taking the time to watch this video. For more information and to download ADIsimRF, please go to analog.com/ADIsimRF.